Hey y'all, we are Memphis Communiversity and we're back for another Calculus Done Wrong lesson where we wrong calculus before calculus wrongs us. Today we're going to be doing quite a weird lesson. This is the conclusion of our shape of curves unit, but we're not going to ask questions like where does f have a relative min or max or where is f concave up or down. We did that in previous videos. Today we're going to cover three types of multiple choice questions that deal with the shape of curves, but they're kind of weird and they're kind of dumb sometimes. So these three questions are the questions where the answer choices are all tables, 2-column tables. Then we have the questions, the possible, not possible questions, where we're going to try to draw a line for those functions. And finally, we have the dumb questions, where we don't have much information, and our shape of curves rules actually doesn't help us very much. So keep in mind that, again, these questions aren't that important compared to our normal shape of curves questions, like where is f concave up? These questions do involve shape of curves, using those rules, but they're not on the rules themselves. So these questions that we're going to cover in this video probably will not appear on the free response question. They do appear on the multiple choice, and we want to get every single multiple choice question right because we want to show them what we can do. So we might as well still cover them. But again, they're not the craziest thing in the world. They're not the most important question in the world. But we still want to get everything right, so let's talk about them. So again, we're doing shape of curves, miscellaneous. Basically multiple choice questions that are a little bit of miscellaneous topics all jumped together. And again, there's three types, and we're going to try to do 2 examples of each type. So the first type requires me drawing these tables. So if you want, you can maybe fast forward through these tables. If you want to listen to me talk as I construct them, that's perfectly fine as well. But basically, you're going to have these tables, and these questions, all these questions look the same. So you're like, oh, this is the table question where all the answer choices are tables. So it's going to be like something like 3, 4, 5. You're going to have something like 0, 1, and let's say 3. Then you're going to have x, f of x. You're going to have 3, 4, 5 again. So each of these tables will have the same x column and won't have the same y column. So it'll be something like, I don't know, -1 and 2. And then we have c, we have d. Again, each of them have the same x column but different y values. So we're going to flip this, and then we're going to flip this one to find this answer choice. And again, as I look at the question and I just look at the answer choices, I know exactly what to do because again, these questions look very familiar. So in these questions, you're going to have these 2 basic givens. You're going to have more words probably because you're going to have a nice little sentence as their question. Basically what they're saying is, I know a function is f prime is positive and I know that its second derivative is negative. Which of the following 4 answer choices, again, we're doing multiple choice questions, could this represent our function? So which of our functions could be represented by one of these 4 tables? So what I like to do is I like to really ignore these 2 facts right here, and I like to add a 3rd column to all of these tables, which I call the f prime column. So keep in mind that this column is a little bit misleading because you don't know exactly f prime values, but you can sort of approximate f prime values, the derivative values, calculus slope, using algebra slope. So what we're going to do is we're going to take the first 2 rows, 3, 0, and 4, 1, and find the slope between those 2 points. And keep in mind that finding slopes is very easy usually in these tables because the x's are separated by 1, so you're really dividing by 1, so the slopes are really the difference in the y's. So in this case, I'm going to form these like greater than angle arrow things, and I'm going to write a number here, and this number is to represent the slope between this and this. So in this case, it'll be 1 minus 0 over 4 minus 3. That slope is just 1. Then we have 3 minus 1 over 5 minus 4, that's 2. And if you want to keep going, well, we have 1 minus 1, that's 2 over 1. Finally, 2 minus 1 over 1, that's 1. So again, this is an approximation, f prime value. Not exact values, but at least an approximation. Finally, we have this one and this one, we have this one and this one. So this one's going to be -2, this is going to be -1, 1 minus 3, 0 minus 1. Be careful when you're doing bottom number minus top number when you have these negatives. And then this one is going to be -1 and -2. 1 minus 2 and -1 minus 1. So then what you do is you finally look at your givens. And because I love shape of curves so much, they sort of govern my life, I want to use them as much as possible. So I'm going to use this first given, f prime is 0. And remember that the rule is f is increasing when f prime is positive, f is decreasing when f prime is negative. So what I'm going to look at, some people look at the f prime column, that's perfectly fine, but I'm going to look at the f column. So the rule is that f is increasing when f prime is positive. So So notice that as I go down this column, as I get bigger and bigger x values, I get bigger and bigger f values. It goes 0, 1, and 3. So that means that f is increasing, which means that f prime is positive. And that seems like it's the case because I have positive values in my f prime column. So this has f prime positive. Over here, it looks like f prime is positive as well. Negative 1, 1 to 2, those numbers are getting bigger. So that means that f prime is positive because f is increasing. The f column is increasing. Here, the f column is decreasing, 3, 1, and 0. The rule is f is decreasing when f prime is negative. I like to recite my rules before I go to sleep so that I know them very, very well, and that's one of them. F is decreasing, 2, 1, negative 1. That means that f prime is negative. Then what I do is I do the same thing, but with my f prime column, because remember that the rule is f is concave up when f prime is increasing or f double prime is positive. So f double prime is positive is the same thing as f prime increasing, f double prime is negative is the same thing as f prime decreasing. So I'm looking at my f prime column, increasing, decreasing, to tell me about my sign of f double prime. Same thing I did with the previous thing. Look at my f column and see whether that's increasing or decreasing to determine about my f prime sign. So in this case, we are going to do f double prime is negative. So let's see here. Well, 1 to 2, that's increasing. F prime is increasing. That means f double prime is positive. Here we have 2 to 1, that's decreasing. F prime is decreasing. That means that f double prime is negative. Here we have negative 2 to negative 1. That means f double prime is positive because f prime is increasing. Negative 2 to negative 1. Sorry about the hesitation. Then we have negative 1 and negative 2. That means that the values are decreasing. So it's f double prime is positive here. Sorry, it's negative. Don't know what I'm doing. Because if we go down from negative 1 to negative 2, if f prime is decreasing, that means f is concave down, f double prime is negative. So then what you do is you look at your givens finally and you just determine which one matches the right givens. Notice that the answer choice is going to be this one right here because I want f prime to be positive so the f column is increasing, and I want f double prime to be negative so that the f prime column is decreasing. But you can easily change these inequalities and then you would get different answer choices. For example, if they were both positive, it would be this one. If you changed both of these around, negative and then positive, there would be C. And finally, if they were both negative, it would be D. So again, what I do is right when I see these questions, I construct an F prime column, and then I use whether F is increasing or decreasing to tell me about the sign of F prime, and then I use my F prime column that I created to determine the sign of F double prime. So that's how these questions work. There's not much variation in these questions. We will do a harder one right now. So let's see how it works. But again, form your F prime column, determine signs of the F prime and F double prime based off the column at F and the column at F prime, whether those are increasing or decreasing. So let's do a new set of 4 tables for a new question. So let me erase this. Let me see if I can write the right column. So again, you can probably fast forward through this as I try to make these columns off the top of my head. Let's say we have, let's say 1, 2, 3, so keep it pretty light. And let's say we have, can't erase here. Let's say we have 4, 5, and let's see, 7 is what I want. Then we have something like 1, 2, and 3, and we have 3, 5, and 6. Then we have another row. Hopefully I'm not messing up here because that would be embarrassing. But let's say we have 4, 5, and 8 instead. And finally, let's say we have 3, 5, 2, 5, and 7. So these are going to be my new 4 tables. There's going to be stranger givens in this case. In this case, the givens are going to be that f prime is f prime of 2 is equal to 2. So they're going to give me an exact value of f prime at one point. That's going to be at x equals 2. And then they're also going to tell me that f is strictly concave up. But again, when I do these questions, I don't look at the givens. I like to construct my f prime column. So let's do that real quick. So it shouldn't be too bad again. All you're doing is you're doing slope where they're separated by 1. So it's really just the difference in the y values. So in this case, it's going to be 1 and 2. Over here, it's going to be 2 and 1. 5 minus 3 over 2 minus 1, 6 minus 5 over 3 minus 2, where this number represents the slope between 2, 5 and 3, 6. Then you have this f prime column, which is going to be 3, not 3, 1. This is 3, because 5 minus 4, 8 minus 5. This is going to be 3 and 1. So then what we do is we look at our given. So let's look at this given because it's a little bit, it tells us a little bit more about the stuff. So here f is strictly concave up. Remember that's the same thing. You can change this given as f double prime is positive. And remember for f double prime to be positive, that means f prime is increasing. So we're going to look at our 4 columns and we're going to determine which column that we constructed, our f prime column, whether that's increasing. Looks like A is a valid answer because 1 goes to 2, that's increasing. So that's a possible answer choice. B doesn't look like it's a possible answer choice because it goes from 2 to 1, so that's probably wrong. Again, it's f prime is decreasing. That means that f double prime is negative, which would mean that f is strictly concave down. In this case, we have 3 and 1, so it looks like D, again, is the wrong answer choice because f prime is decreasing. That means f double prime is negative, f is concave down. In this case, we have a potential answer choice 1 to 3 because we're increasing. So that means that f is still concave up because f double prime is positive. So it looks like we have A or C and we can't really roll it down, so we must have to use this point in order to answer it down. It's nice to roll it down to 2, of course, but we want to answer the question correctly, so let's try to see how this works. So remember that we are constructing an f prime column, and it's an approximation of an f prime column, but they gave us a value of 2 actually. They told me exactly what the slope is, the derivative is at 2. So what I'm going to do is I'm going to squeeze in this slope of 2, where it corresponds. And again, it corresponds to the middle part because we know that f prime of 2 exactly is 2, where this number is to represent the slope between these 2 points. This number is supposed to represent the slope at these 2 points. So if we know the slope at exactly 2, well, we can just squeeze it in the middle. Same thing for this answer choice that's potentially right. And notice that when we do squeeze in the middle, the word strictly is very important because notice that this one goes 1, 2, 2. That's not strictly increasing. This one is 1, 2, 3. You're actually becoming bigger, whereas this one has stayed the same number, 1, 2, 2. So this one could not possibly be the answer choice, so it has to be C. So hopefully you see that we did the same exact thing as we did in the first case. When you see this sort of question where all the answer choices are these 2 columns, then what you want to do immediately is you want to find an f prime column, add to each of the tables. Then what you do is you look at whether f is the f column is positive or negative, or increasing or decreasing. That tells you about f prime being positive or negative. And then the f prime column being increasing or decreasing tells you about f double prime being positive or negative, based off our shape of curves rules. And finally, if they give you a middle value, you squeeze that in between. And that's how you do these table questions. Hopefully that's enough in order for you to answer these questions. But I'm going to talk about now questions that I found a little bit harder, which are the possible and not possible questions. So let me erase this. So the first possible, not possible question I'm going to do, this is the second type of question. It's totally different. Suppose we know that f of 1 equals -2, and then we have that f prime of x for every single number is greater than, let's say, 2. And then finally, we're trying to determine what are possible and not possible values given that x satisfy these 2 equations. So we were going to do possible and not possible values of f of 3. So possible or not possible. And the answer choices are going to be y values. So it's just going to be 4 y values. So if they're asking possible values, 1 of them will be possible, 3 of them will be not possible. So those are the wrong answer choices. And finally, when you have not possible, 1 of them is going to be not possible, 3 of them are going to be possible. So again, these are multiple choice questions. We might not include multiple choice answers, but they do appear on the multiple choice section. So what I like to do in this question is I like to draw a picture. I found like this is the easiest way for me to teach my students how to do these questions. So again, f satisfies these 2 things, and we're saying, what could f of 3 be? Could it be 7? Could it be 27? Could it be -1? Could it be 0? We don't know. So what I like to do is I like to plot this point right here. So let's just plot this point as accurately as possible. So it looks like we're going to be at 1, and then it's going to be -2, so we're way down here. So then what you do is, while this does say greater than or equal to, what we're going to do is we're going to just pretend that it says equal to 2, because it's easier to deal with if it just says equal to 2. So what we're going to do is we're going to take this x value, which is the given x value, and we're going to try to find a possible y value, given that we're going to start at the point 1 comma -2, we're going to use this slope of 2, and we're going to try to get to a y value along this line at 3. So what that's going to tell is that we're going to start at this point, 1 comma -2, and then we're going to rise over run until we get to the x value of 3, and we're going to see at what y value we arrived at. So how does that work? Again, we're going to be at 1, -2, so we're going to rise 2, run 1. So if you rise 2, run 1, you're going to end up at the point 2 comma 0, rise 2, 1, run. And then when you rise 2, run 1 again, it looks like it's going to be at 3, and you're going to be at the point 3 comma 2. And we're going to form a nice little line segment, hopefully going through all 3 points. So again, I start at this given point of 1 comma -2, and I'm pretending that the slope, meaning the derivative, is exactly equal to 2, so that I'm rising and running until I get to the y value of the x value, that is the desired x value. So in this case, the desired x value is 3. So we got to 3. If you wanted to, what you can do is you can form the equation of a line using this point and this slope, and then you can plug in 3. That could be another way to do it with algebra. But in this case, it looks like we arrive at the point 3 comma 2. So keep in mind that this y value right here is usually not the answer choice, but it's an answer choice that helps us determine what are the possible and not possible values. But again, I'm going to talk about how to arrive at this point, because this is the most important step. So you plot the given point 1 comma -2, then you use your given slope to arrive at a y value using rise over run, or whatever you like to think about slope as. So rising 2, run 1, rising 2, run 1. Be careful if the slope is negative, for example. And in this case, we get to the point 3 comma 2. Finally, we're going to look at the greater than or equal to signs. So basically, this y value of the given point 3, this might not be the answer choice, but what it does is it separates the entire plane into possible and not possible values. So notice that if our slope was exactly 2, we would get to the y value of 2. That's what we did here. So 2 is a possible y value. What if our slope was greater than 2? What if it was slope like 7 or something? Then we would be way above here. Same thing if we had slope 4. Because slope 4 is steeper than slope 2, we would have run and rows, I guess, is rise and run, at a steeper value. So you're going to be getting higher and higher values that are bigger than 2. So what I argue is that these are that's the worst curly brace I've ever drawn. These are the possible values. So, for example, possible y values for f of 3, depending on that the slope is greater than or equal to 2. Well, if it was equal to 2, we got to the y value 2. Other values that are possible are something like 4, if your slope is steeper than that, if your slope is greater than that. Same thing with 7, 12, 15, 100. Anything bigger than 2 or equal to 2 are the possible values. Now imagine that we have slopes that are not possible. For example, slope 1. Well, if you have slope 1, you would be arriving at a y value that's below this line. So in this case, these are the not possible values. So those are the slopes that are less steep than 2, so you're not going to be able to rise and run as high as you get to at 2. So for example, if we want to actually make this an answer choice, what if we ask what is a not possible value for f of 3? And then we have the answer choices A, B, C, and D. And let's say the answer choices are something like 1, 2, 3, and 4. Well, 2, 3, and 4 are all possible because 2 is the one that you hit exactly, and then 3 and 4 are above. So the possible ones are y greater than or equal to 2. The not possible ones are y less than 2, which is going to be 1. So that's why it's this answer choice. So hopefully you see what we're doing here. Again, what you do is you plot your given point, 1 comma -2 in this case. Then you rise over run, pretending that the slope is exactly the number. You rise over run until you get to the x value that's desired. You look at that y value. Usually it's not the answer choice, but I'll tell you the possible and not possible values. In this case, it splits it into 2 parts. The ones above it are the possible ones, because those are the ones that are met through greater than or equal to slope. The ones below it are the negative ones. Those are the ones that have less steep slope. The negative values of slope that are like 1.5, 1.9, -5, 0, whatever. All of these are the not possible ones because you're not going to be able to rise over run to get to that point. So that's how you do these questions. Let's do something that's pretty similar. Let's do another possible, not possible. Again, these questions are very, very tricky because they're somewhat conceptual and you have to draw pictures and things like that, but they're not impossible to answer. So the next thing I'm going to do is I'm going to ask the question f of 2 equals 4. Let's suppose we have that given. Suppose that we know that f prime of 2 is equal to, let's say 3 this time. And let's say we know that f double prime of 2. So again, these are some givens throughout the question. F double prime is 2, -1. And then let's say we even have some more givens. Let's say we know that f prime is always positive and f double prime is always negative. And again, what we're trying to do is we're trying to determine possible and not possible values for another number. So the number in question will be f of 4. So the question is, if f satisfies all these givens, could f of 4 be 7? Could f of 4 be -2? Could f of 4 be 3 itself, 0, -1, whatever? So that's what we're going to try to determine. And again, the best way, in my opinion, to do these is to try to draw a picture. So we're going to try to draw a picture. So let's try to draw a picture here. So let's do f of 2 equals 0. So again, the first thing I like to do is plot this point. It's the easiest part of the question. Plotting the point 2, 0. So it's going to be 2, 0. Then what you do is you're going to use this slope. So notice that this slope is only about f prime of 2. It's not the slope at any of the other points. But just like the other one, when we had the inequality and we just thought of it as equality, we're going to pretend that this slope holds for every single thing so that we get to a y value that will help us determine which ones are the possible and not possible values. So again, even if f prime of 2 is equal to 3 only at x equals 2, we're going to pretend that f prime of x equals 3 everywhere. So what we're going to do is we're going to have slope 3. This is supposed to be an m. So we're going to cover up f prime of 2 equals 3, and we're just going to pretend that slope is 3 everywhere, and we're going to get to our y value of 4. So notice again, it's going to be rising 3, running 1. That'll give us our y value at 3. So that's going to be 3, 1, 2, 3, I believe. But that's not the y value we want, because the y value we want corresponds to the x value of 4, and we're only at the x value of 3, so it looks like we have to rise over run again. So it's going to be 1, 2, 3 again. Rising 3, running 1. Let me see if I can have a better, more accurate increment. So it's rise 3, run 1. So it's going to be somewhere around here. We started off at 2, 0, so this graph is not super perfect. But hopefully we can draw a line. Not my best line in the world. Let me just try one more time. So 3, 3, somewhere right here is better. Here. That should be good enough. So again, we're going to label this point because this point is very important. It's going to be 4, 6. And again, how we arrived at it is we started at 2, 0. We rose 3, ran 1. And then we rose 3 and we ran 1. So we ended up at 4, 6. But again, we sort of took a given for granted. We said that f prime of x equals 3, but it was only f prime of 2 equals 3. So now we have to determine possible or not possible values. So first off, we know that f prime is positive everywhere. What does that mean? That means that the function is increasing. So an easy way to rule out some values is know that all of these values are not possible. If we start at the point 2, 0, we cannot go down because f prime is 0. Then we have the fact that f double prime is negative. That means that f is concave up. So that means that we're going to have, or concave down, f double prime is negative, so it's concave down. So that means that no matter if you try to draw this line, in order to draw a concave down function, it has to be underneath this line. Because basically what this is saying is that our slope has to be less than 3. Because our slope is decreasing. F double prime is negative means the f prime is decreasing. So it's not going to be exactly 3, it's actually going to be a slope of 2 or slope of 1. So I argue that these are our possible values actually. And anything above this is actually not possible because that would mean f double prime is positive, meaning that your slopes are getting bigger and bigger and bigger. So everything above this are actually not possible. including 6 itself, if f double prime is strictly negative and f prime is strictly positive. So for example, if we were doing possible values at this time, and we had the answer choices, well, -1, we had the answer choice 4 itself, we had the answer choice 6, and we had the answer choice 9. We want to choose the one that's in this band between 0 and 6, so that's going to be B, because we don't want to include the interval, because again, we have something strictly increasing or strictly concave down. So hopefully this makes sense. I'm not sure if I'm explaining this the best way, but let me just repeat what I did. I started at the point 2, 0. I pretended that the slope was exactly 3 to arrive at a point with x coordinate 4, and it happened to be that the y coordinate was 6, rising and running twice. Rise 3, run 1, rise 3, run 1. Then I use my fact that f prime is 0 and f double prime is negative to try to determine which ones are the possible and not possible values based off this point 4, 6. Everything below the original point is not possible because of the increasing part. And then because we have something concave down, we wanted these values. If you wanted to draw a concave down function, it's impossible to draw a concave down function that is above this line. Something like this is concave down, concave down, concave down. Notice which values we're hitting. We're hitting all the values in this band right here. So these are the answers that you want. Anything above it would be concave up because your slopes would be increasing, so you'd have steeper and steeper slopes. So hopefully that makes sense. Again, these questions are tricky. We do recommend trying to draw a picture and try to think about possible and not possible values by finding certain points and thinking about slopes, what happens if the slope is greater than whatever, what happens if the slope is less than whatever. But again, don't feel discouraged if you don't know how to answer these questions, because these questions are very tricky. They're some of the hardest multiple choice questions on the AP exam. Let's do some of the dumbest questions on the multiple choice AP exam. That's going to be what we're going to conclude the video with. So let's say we're erasing this. And let's say we have a function that satisfies the following table. So our table is going to look something like this. We're going to have some nice x and f prime values. Let's say we have 2, 3, 7. So these are just random numbers off the top of my head. Let's say we have something like -2, -1, 0, 3, 6, and then finally we'll add some last row, 10 and 4. So this is going to be my row, and what it will say is that f satisfies some of these questions. F has an f prime that satisfies these tables in the column. So for example, I know that f prime of 8 equals 3, and the question is a true or false question that is very, very tricky and very, very deceptive. So in this case, the question is, what is true about f? So my answer choices are going to be A, f is increasing from 8x to 10. Then my answer choice B is that f is concave up from x2 to 8. Then my next one is going to be f has a row min, or a local min, at x is equal to 7. And then finally, I'm going to say that f has an inflection point somewhere in the interval and the interval 8 to 10. So these are my answer choices. So let's just talk about each of them, and this is a good time to review sort of shape of curves rules, probably more important than actually answering this question correctly. So again, the question is f is increasing. Let's take each answer choice one by one and apply a rule. So the first question is f is increasing. What's that rule? Well, f is increasing when f prime is positive. So what we're going to do is we're going to look at this table and see if it's positive. Well, on this interval 8, 9, and 10, it looks like it's positive, 3, 6, and 10. So look, 3, 6, and 4, sorry. Those are all positive numbers. So it looks like we're done here. Answer choice A is the answer. But unfortunately, we don't know f prime values in between. It's a really tricky standardized test question where they're really trying to trick you, and trickers get tricked. So why is A actually not true, even if the values in the table look like they're positive? It's because we don't know the values in between. For example, we don't know what f of 9.5 is. It could be -20. And if we're -20, that would mean that f prime is negative, so that means f is decreasing. So this is why I consider the questions to be dumb, because they're trying to trick you in these questions. So while this looks to be true, because we don't know the values in between, this one is actually false. Same thing with the next one. F is concave up. Let's first think about the rule. Well, F is concave up when F prime is increasing. So we look at our row from 2 to 8, and it looks like these values are increasing. -2, -1, 0, and 3. So those values look to be increasing. Unfortunately, we don't know any of the values in between. So for example, while it might go -1, 0, -2, -1, 0, 3, all those values are increasing, we don't know the value at, for example, 4. So let's say that f prime of 4 happened to be -5. Then it would be -2, -1 increasing, and then it would suddenly start decreasing at -5. So again, this one is false as well, because we don't know the values in between. Let's answer this question about local min. So local min is f prime goes from negative to positive. It's the same thing as a relative min, of course. F has a relative max when you go from positive to negative. So if you look at this answer choice right here, if you look at the value x is equal to 7, then if you look at this and you're like, oh, well, this seems to be true because you're going from negative to positive. That is our local min. But unfortunately, that is false because you don't know the values in between again. It could bounce immediately after 7. So it could go -1 to 0, back down to negatives, and then go to 3 eventually later on, in between 7 or 8. We don't know if the relative min is exactly at x equals 7, because again, we don't know the values in between. So that's why this question is wrong. The answer choice, of course, is D, because we ruled out all the other answer choices. But let's talk about the rule for f has an inflection point. Well, the rule is, this rule was f prime negative to positive for f is local min. Important to know the rule, but again, it wasn't satisfied because you don't know the values in between. For f inflection point, the rule is f prime goes from increasing to decreasing, or decreasing to increasing. By the way, this function is continuous, because you can't answer any questions unless the function is continuous. So here, if we have a continuous function, a twice differentiable function so that its derivative is also continuous, we have f prime increasing, f prime decreasing, increasing. This is true because notice we go 3 to 6 to 4. So we have 3, we have 6, we have 4. No matter what, as long as you draw these points, as long as this f prime is a continuous function, so we can say that this is differentiable. Let's say it's twice differentiable, so that its derivative is definitely continuous as well. So if it's twice differentiable, meaning that you can take two derivatives, meaning that f prime is continuous, no matter what f prime looks like, it has to start right here, go up to here, and then eventually come down to here. It might not actually happen at this point, because you don't know the values in between. So for example, it could have looked something like this, but no matter what, it will have a point of inflection somewhere. This answer choice is less specific than the answer choice that occurred before it. And the one that occurred before it, it said that this has to be a local min. And the one after it, it says it just happens to happen somewhere in the interval. So it will happen somewhere in the interval. You don't know where it's going to happen. It might not happen at the 0.9, but it does happen somewhere. So that's the dumb question. Again, these multiple choice questions are meant to trick people, in my opinion, which is what makes it dumb. But knowing the rules is certainly lovely, but actually the rules don't help you very much because you don't know the values in between. Keep in mind that the dumb questions aren't dumb if they add an accompanying sentence. So let's end it with that. So let's say we have a similar table. And let's say we have this table right here. And then we have f double prime values instead. Let's do 5, 0, let's do something like 8, 0, and -1. And let's say we have this as well, where we have that f and all of its derivatives. I don't know how to spell the word its. Derivatives are continuous so that everything is nice and dandy. So we don't have weird jumps and stuff like that. So let's say that we have an accompanying sentence so that we don't only have the given as the table, but we have an accompanying sentence that f double prime is strictly decreasing. This question right here changes everything. So for example, because we know that f double prime is strictly decreasing, we know that it has to go from 8 down to 0 down to -1. It can't go up, for example, because even if we don't know the values in between, we do know something about the values in between, and that it's always decreasing. So for example, we have a sentence like this, statement 1, f is concave up from x between 2 and 4. While in the previous answer, this was not going to be a potential answer choice because we don't know the values in between. For example, f double prime of 3 could have been negative, so that breaks this rule because the rule for f is concave up is f double prime is positive. We know that because f double prime is strictly decreasing, it cannot be negative because if there was a negative value, you can't go back up to 0. So this accompanied sentence for this table makes the dumb question not dumb. Your actual shape of curves rule will help you because you can actually know the values in between, even if you don't know them exactly. So f is concave up from x between 2 and 4. That's true because these values are going to be in between 8 and 4. So this is a true statement. Same thing for the statement, for example, that f has an inflection point at x is equal to 4. It looks like this statement is too exact, but because of this accompanying sentence, this actually is a true statement because f double prime changes signs and it goes 8, 0, negative 1. Unlike the previous example, without that sentence, we didn't know if this point it bounced at this point or whether it went through the point and went crossed through later on or something like that. But in this case, because we know f double prime is strictly decreasing, it cannot bounce at this point. It has to go 8 to 0 to negative 1. It can't go back up because then it would break this sentence. So this one is also true. So hopefully that makes sense with the dumb questions. We did talk about 3 types of miscellaneous questions and they did vary in difficulty and they are not the most important thing. Again, we talked about at the beginning of the video, the questions where all the answer choices are 2-column tables where we constructed f prime tables and then we used that f is increasing or decreasing, f prime is increasing or decreasing, determine the signs of f and f prime and f double prime. Then we did the possible and not possible questions where we pretended that slopes were certain things, we found points, we used slopes, and we determined from those slopes whether things were possible or not possible in terms of y values. Finally, we answered these dumb questions where if there's no accompanying sentence, you don't know the values in between, so usually your shape of curves rules won't help you very much, where if you do have an accompanying sentence, then it becomes a normal question. Of course, even if these questions don't appear as often as our normal questions of shape of curves, you can still certainly practice this. And what I'm going to do is I'm going to link the Girls Teach Calculus video, our normal Girls Teach Calculus video, in the description of this video, where one of my former students practiced several of these questions. She does 2 of the table type of questions, the 2-column tables. She does some possible and not possible questions. And finally, she does these dumb questions, potentially dumb questions, if there's no accompanying sentence. So be on the lookout for that if you want to be able to master every single question on the multiple choice, even these less important ones, because they do come in patterns and they do sort of resemble ones from former AP exams. So thanks again for watching. This has been a strange video because of the content of this video. Hopefully I'll see you next time whenever that next time occurs. Thanks again for watching and I hope to see you next time.